Certified Technical Sales Professional Training Course. Agenda. The presentation will comprise an introduction to Nozomi networks, a brief overview of what operational technology is, a quick look at OT security threats. I'll then provide a Nozomi networks solution overview, explain the Vantage Cloud architecture, talk about proof of concepts, outline our professional services offerings, and lastly, explain where to find help. There is a 30-minute online test associated with this training course, which you can take once you've watched this video, and you will have 3 attempts to get over 80%. As we go through the presentation, you will see some of the text is in red. This typically means there is a question in the online test associated with this section. Who is Nozomi Networks? Nozomi Networks was founded in Switzerland in October 2013 by Andrea Carcano, who was looking into OT security as part of his PhD, and Moreno Corello, who was studying artificial intelligence. Andrea realized that the large oil and gas company he was working for had no real visibility into their OT environments, so started developing a solution with Moreno to provide visibility and security monitoring. With no interest from the oil and gas company to develop software solutions, Andrea and Moreno formed Nozomi Networks. Global footprint. Nozomi Networks was formed and our solution is still developed at our European headquarters in Mendrisio, Switzerland. We also have global headquarters in San Francisco. Our customer base now includes over 5,000 installations, monitoring in excess of 57 million devices across 6 continents. To reach this scale, we rely heavily on our partner network, which now includes over 1,000 certified professionals. We have a proof of concept conversion rate of greater than 80%, and when it comes to customer satisfaction, we have a 100% customer retention rate. That is, we have never lost a customer. Net Promoter Score is a measure of how good support is, and anything over 7 is meant to be world-class. Nozomi Networks' NPS is around 9, which is virtually unheard of. Securing the world's largest organizations. Nozomi Networks' initial deployments were in oil and gas, where we are in 9 of the top 20, and pharmaceutical, mining, and utilities, where we protect at least half of the top 10. These are historically our key verticals. However, Nozomi Network now protects many more industries, from automotive manufacturing, utilities, transport, food and beverage, in fact, anywhere OT or IoT systems are used. So what is operational technology and the Internet of Things? OT networks connect to the real world. The primary component of all OT systems is the industrial controller. These are specialized computers that run relatively simple programs that take the current status of an industrial process via inputs and modify process operation via command outputs. Inputs can be digital, such as the on-off status of a motor, or analog values, such as a depth of water in a reservoir. Similarly, outputs can be digital, such as a command to switch a baggage conveyor on or off, or analog, such as a command to speed a motor up to, say, 400 revs per minute. You'll see on the left-hand side of the slide references to the Purdue model. This is a model used by IEC 62443 to classify the different parts of an OT system. The inputs and outputs that connect to the process sensors and actuators are classified as Purdue level 0, whereas the industrial controllers themselves are classified as Purdue level 1. It is worth noting that most OT systems were not designed according to these Purdue levels, but can still be broken down according to the Purdue level classification. OT system elements. This slide shows the remaining end devices that make up an OT system. We have the industrial controllers at Purdue level 1, as discussed previously, and at Purdue level 2, we have operator and engineering workstations. Operator workstations, also referred to as human-machine interfaces or HMIs, provide operators with a graphical and tabular view of what's happening within the industrial process, as well as allowing a level of control. The engineering workstations are used to make changes to the automation system, such as adding a new industrial controller, modifying the programs running on the industrial controllers, or updating controllers to the latest version of firmware. There will often be an automation server also at Purdue level 2, which has responsibility for providing process visibility and control capabilities to the operator workstations, rather than having multiple individual operator workstations communicating directly with the industrial controllers. Purdue Level 3 is where the IT elements of an OT system are found, such as antivirus management systems, domain controllers, and database management systems, also known as historians. Purdue Level 4 sits above Purdue Level 3 and refers to the corporate IT systems. Typically, there's an industrial DMZ that sits between Purdue Levels 3 and 4 to cater for those devices that need to speak to both OT and corporate IT systems. This is referred to as the Purdue Level 3.5. OT control room. OT systems will typically have one or more OT control rooms. In this slide, you can see multiple operator and engineering workstations built into a desk with multiple large wall displays providing overall status of the industrial process. This would be considered a medium-sized control room. IoT. The Nozomi solution also provides visibility and security for IoT systems. IoT referring to the Internet of Things. These IoT systems typically comprise intelligent end devices communicating back to traditional computing platforms rather than industrial controllers, and typically use HTTPS or specialized communication protocols unique to the demands of IoT, such as MQTT. Smart metering systems used by power companies are a good example of IoT systems, and Nozomi protects a number of extremely large deployments, sometimes with over 10 million meters. Likewise, Nozomi is deployed to protect CCTV systems with many hundreds of cameras. OT and IoT security threats. Example 1, stucknets. No discussion about OT would be complete without referring to stucknets. Stucknets was developed by the US and Israel to slow the pace of nuclear enrichment at Natanz in Iran. It effectively took over control of the centrifuges being used to enrich the uranium and spun them in a way that destroyed them, all the time cloaking the activity so operators manning the HMIs were totally unaware of what was going on. Not only was this nation-state developed malware very sophisticated, it certainly showed the world that OT systems were vulnerable to cyber attack. In fact, that OT systems were typically designed with no real consideration of security. Since the attack in 2010, attacks on OT systems have risen exponentially. The high cost of a cybersecurity incident. This slide shows a table of some of the high-profile cyber attacks on OT systems over the last 10 years or so. What's interesting is that many of the attacks are related to criminal gangs using ransomware to make money rather than nation-states strategically targeting the other country's critical infrastructure. Not all the companies affected by these cyber attacks were targeted. In many cases, they were simply infected with malware that was doing the rounds. Of particular concern was the Triton attack on a Saudi petrochemical company. This attack was directed at the safety shutdown system, which is effectively the last line of defense when things go wrong with the main OT system. Had the perpetrators been able to attack the main OT system whilst the safety shutdown system was compromised, the potential for catastrophic incident would have been huge. Although difficult to put a number on the average estimated cost of a cyber attack, the figure is thought to be around $1 to $2 million. IoT-specific attacks. IoT systems are also under attack from cybercriminals. The vast number of these devices and their often inadequate security safeguards make IoT an attractive target for launching DDoS attacks or for infiltrating corporate systems, or in the case of CCTV in particular, simply eavesdropping on their videos.